Let's do the extra practice problems for Chapter 4. Number 1, one of the following orbitals represents a 1s orbital and another represents a 2s orbital. Indicate which one represents each. A is spherical, so that's an s orbital. B is the shape of a p orbital, where it's got a dumbbell shape. C is spherical, so that would be an s orbital. And D is actually a p orbital once again. And so the 1s has to be A because it's the smaller sphere, and the 2s has to be C because it's the larger sphere. Okay, number 2, give the ground state electron configuration for the following elements. Beryllium. Beryllium is right here. It's number 4. So you're going to go top to bottom, left to right. So you're going to go 1s2. We're on the second level, 2s1, 2. And so there's your 4 electrons. The next one is carbon. So carbon is right here. So we're going to go 1s2. We're going to go across that first line. Then we're going to go 2s2. So we go across here. That brings us over to 2p1, 2. So we're going to go 2p2. And notice carbon is 6, so it has 6 electrons, and here's your 6 electrons. The next one is argon, which is over here. So we're going to go 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4, 5, 6. So let's do that. 1s2. So we got to cross this first line. 2s2. We got to go all the way to the end there. So 2p6. And then we're down here. 3s2. Now we're over here. 3p6. Please notice that argon is 18. And if you add these up, you have 10 plus 8 is 18 electrons. The next one is selenium. And selenium is right here. Okay? So we're going to start again and go 1s2. And that takes us across this one. Now we're down here. 2s2. So now we're over here. So now we're going to go across there. 2p6. Now we're down here. 3s2, we got to go all the way across. 3p6, now we're down here, 4s2. But when we get here, remember we subtract 1. This is 3d, and we're going to go all the way across, aren't we? So this is going to be 3d10. Then we go back to the 4th level for the p's, and we're going to go 1, 2, 3, 4. So that would be your electron configuration of selenium. And please notice selenium is 34, and if you added these up, you have 10, 20, 34. But using the chart makes it a lot easier. Let's see, now it says, number 3, give the abbreviated ground state electron configuration for Indium, which is right, there it is, Indium. Okay? So we're going to go, but we're going to use the abbreviated, thank you, Jesus. We're using the abbreviated one. So what we do is we go to the, it's here, so we're going to go to the noble gas above it, which is going to be here. And that is krypton. The abbreviated version would be Kr, and then we come down here, and it's 5s2. Then when we get to this, we're going to take off 1, so that's going to be 4. 4d10, because we're going to go all the way across here. Then we get back to 5, and this is the p orbital over there, and it would be 5p1. And so that would be our indium, the abbreviated electron configuration. Then we get to number 4. What is wrong with the following electron configurations? So let's run through it. 1s2, 2s2, 2p6, 3s1, 3p6. You would have to fill that 3s orbital with 2 electrons before you would go on to the 3p. So that's what's wrong with that one. B, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then it should be 3d10 before it goes on to 4p. So that's what's wrong with that one. And C, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, good, 4p6, 5s2, but then it goes right on to the 5p orbital, and it's missing the 4d. So it would have to have the 4d10 before it would go on to that 5p orbital. So that's what's wrong with that one. Number 5, what element has the electron configuration? So if you look at your chart and go to the 3D4 place on your chart, 3D4, this is 4s, so this would be 3D, and we would go 1, 2, 3, 4. So the answer would be chromium. Number 6, which of the following elements should have very similar chemical behaviors? All right, potassium is here. Take my little sheet with me. Potassium is here. Selenium is here. Silicon is here. Thorium is way down here. And sulfur is here. These two are the only two in the same column, and therefore sulfur and selenium are the two that have similar chemical behaviors, because remember, to do that they have to be in the same column. Okay, next we're supposed to draw the Lewis structure for phosphorus. Phosphorus is in group 5, therefore it has 5 valence electrons, so you would phosphorus 1, 2, 3, 4, 5. And that would be our Lewis structure for phosphorus. The next one asks us, so that's number 8, draw the Lewis structure for the ion that nitrogen forms in an ionic compound. Well, nitrogen is here in 5. And so nitrogen normally would be 1, 2, 3, 4, 5. But in an ionic compound, it wants to reach 8. So it's going to snag 1, 2, 3 electrons in the process of making an ionic compound. Therefore, its Lewis structure would actually show these electrons, but it would also show it with a -3 charge because it has gained 3 electrons. Remember, it was 5 valence, and now it's got 8. So 5 minus 8 is -3, and therefore it would end up with a -3 charge, and we would call this a nitride ion. Remember, the negative ions take on the "ide" ending, so it would be a nitride ion. Number 9, draw the Lewis structure for the calcium, the ion that calcium forms in ionic compounds. And what is its name? Calcium is right here in group 2. Therefore, it has 2 valence electrons. But remember, because it's a metal, because nitrogen was a nonmetal, so it received electrons in an ionic compound. This one is a metal. It gives away the electrons, so it's going to get rid of those. So it's going to be this. And the name of that is just going to be calcium ion, because it is not an anion. It's not negative. It's a cation. It's positive. And therefore, it is just going to be calcium ion. What are the chemical formulas for the compounds formed between these elements? We have calcium, which is in +2. It's in group 2, and it's going to develop a +2 charge. And chloride, which is chlorine, is over here. And chlorine is it's in group 7, so it's going to make a -1 charge. And so you flip-flop this. This gets the 1, this gets the 2. And so this is going to be calcium chloride. B is lithium and sulfur. Lithium is right here. It's a group 1 metal, so it's going to take on a +1 charge. And sulfur is down here. It's group 6, so it's going to take on a -2 charge. And so This one's going to get the 2, this one's going to get the 1, and so that would be lithium sulfide. Remember the ionic compounds, you just name the first one and name the last one as an ion. Aluminum is over here, so it's a metal though, and it's in group 3, so it's going to take give away 3 electrons, so it's going to be a +3. And selenium is right here, it's in group 6, and so 6 minus 8 is -2, so selenium is going to be a -2. You would flip-flop these charges, and that's how you would write aluminum selenide. I'm not sure how you'd "ide" that, but it would have that ending, the "ide" ending. Sr, which is strontium, was right here. It's a group 2. So Sr is a group 2 metal, so it would take on a +2 charge. And we just did selenium. Selenium was over here, and it is a non-metal in group 6, so it takes on a -2 charge. This is a 1-to-1 relationship, so you just drop the charges, and that's how you would write the ionic form. Number 11, what is the chemical formula for lithium phosphide? Lithium, we found right here, is a +1. Phosphide, phosphorus is down here in group 5, so a 5 minus 8, it's going to grab the electrons, the 3 extra electrons, so it's going to be a -3. So you're going to put the 3 here. The 1 isn't written, it's the invisible 1. So that's how you would write lithium phosphide. Number 12, nitrogen and potassium react to form a compound. Is it an ionic compound? Well, nitrogen is over here, so it's a nonmetal, and potassium is right here, so it's a metal with a nonmetal, and therefore it is an ionic compound. So the answer is yes, it would make an ionic compound. Number 13, what is the chemical formula of chromium 3 oxide? Okay, here's chromium, but they told you its charge when they said Roman numeral 3. So it's chromium 3, and oxygen is over here in group 6, so 6 minus 8 is a -2, and so when you flip-flop those, that would give you chromium 3 oxide. That is actually how you would balance it. Number 4. Iron can take on more than one charge in an ionic compound. What is the name of? And we have FeCl4. Now we look at chlorine. Well, here it's chloride. It's in group 7, so it's going to be -1. So this is a -1 charge, so that's got to be a +4 charge because each of these are -1. So this guy's got to be a +4. So we're going to call this iron 4 chloride. And it's got to have the "ide" ending because that is a negative ion. So iron 4 chloride. And we figure that out, what this Roman numeral is, by looking at what this charge is, and this one has to offset it because the overall charge on a molecule is 0. Number 15, which of the following compounds, when dissolved in water, is likely to produce a solution that conducts electricity? So here we're looking for an ionic compound. The first one is a nonmetal with a nonmetal, so it is a covalent compound. It's not ionic. The second one starts with a metal and ends with nonmetals, and therefore B is an ionic compound, so it should conduct electricity in water. C, it's all nonmetals, so it will not conduct electricity. And D is all nonmetals, it will not conduct electricity. So 15, the answer would be B. That's the only ionic compound there. So that would conduct electricity. Okay, go ahead and finish studying for this. Take your test and read the first half of the next chapter. Have a very blessed week.